With an interest in space travel, our team was tasked with a design challenge on Mars. We were tasked with creating a compliant mechanism that transports material from point A to point B when construction occurs on the surface of Mars.
All right, so here we have our initial design. So a little bit about this. We have a system of 4 boxes. This is the side view. I've labeled them 1 through 4, and I'll explain that in a bit here. The idea was to create sort of a wave-like motion to move the material from point A to point B. So what we had is we had 2 pumps split to alternate boxes. So pump 1 went to boxes 1 and 3, and pump 2 went to boxes 2 and 4. And the idea was to create a conveyor belt on top of these boxes to kind of guide the material from point A to point B, make sure nothing fell off. And so the idea was we would load the material on the conveyor belt above box number 1. And then we would turn on pump 1. And this would raise box 1 and box 3, which would move the material from above box 1 to above box 2. And then we would turn that pump off and turn pump 2 on, which would raise box 2 and 4, moving the material from box 2 to box 3. And this would be continued, alternating which pump was turned on, which one was turned off, creating this wave-like motion to get the material from point A to point B.
In our conveyor belt system, in between each of the sections, there were gaps, and this caused the ball to have a hard time moving from one section to the other. There was also not enough of a height difference in between each section as it moved up and down. This didn't allow for the ball to easily flow from one section to the next. The boxes also weren't secure to the base. This caused a lot of moving around for the boxes when they were being blown up. And the entire system leaned to one side, causing the marbles or the rocks to shift to another side and cause too much weight on that side, and they wouldn't flow.
After several iterations, the team finally developed a compacted mechanism design that allows both marbles and gravel to travel from point A to point B. An increase in height by stacking the boxes onto one another and provide a more efficient slope, which allows the aggregate to travel faster and overcome the friction factor, which was causing the aggregate to stop in the middle of the system. The addition of smooth surfaces and a narrow enclosed channel design helped prevent the aggregate from sliding away from the centroid, as well as preventing the aggregate from falling on the side, and lessen the impact of the friction force. Support beams were added on both sides of the boxes, resulting into a stable system as more weight is added. As seen in the video, column A is raised to approximately 10 inches high, with degree of 39.81. With this, we are able to see that some of the rocks are able to transport smoothly to the crate. However, column B still has to be raised for the remainder of the rocks that are stuck into the system to flow into the crate.
Go, start recording.